Well, let's take a look at this one. If you're not quite done, that's fine. Volume. So this one, we have two definite pieces that we're looking at for volume. We have the cone on bottom, so we're going to do the cone first. And then we have that half a sphere up on top. For the cone, we still have to find the area of the base. That base is a circle with a radius of 11. So that's pi times 11 squared. Gives us 379.94. Is that what you come up with?
Yeah, but you put one with the one.
Yeah, that's 11 squared. I just saved a couple keystrokes. So depending on whether you use the pi keyword, that's about 380. We're going to put it in as 380. So then the volume of that cone, yeah, I do that a lot if you don't notice. I do part of the calculation in my head and part on the calculator. Sorry if that confuses you. So this is in centimeters squared, by the way. So the volume of the cone will be the 380 centimeters squared times that height of 60 centimeters divided by 3. So 7,600 centimeters cubed is the volume of the cone part. So that's just of the cone. The volume of the sphere portion, remember the volume of a sphere is 4/3 times pi times the radius cubed. But we're going to divide by 2 because it's only half a sphere. So that'd be 4 divided by 3 times pi times 11 cubed divided by 2. 2786.23 it looks like. Centimeters cubed. So we add that up to get a total of 10,386.2325, somewhere in there. Centimeters cubed. How many of you had that for volume? 1. That's not a great average. Forgot to divide the sphere by 2.
I was a little off, but I didn't round up.
Now, if you were within, 10,386 to 10,387, you're really, really good. Yeah, that's good. If you're within 5 of that, you'd be really good. On a quiz, I'd probably take anything within about 15 of that. Anybody not know how I got that? Feeling pretty okay. So for the cone, first thing I do is the base, which is this circle, which is the radius of 11. Because if this is a height of 11 on the sphere, that means the sphere has a radius of 11. And so the half, where it's cut in half, that makes that circle that's the top of the cone. That also has to have a radius of 11. So we're finding the area of that circle, pi times radius squared. Gave us the 380, 379.96, somewhere in there. So then for the cone, the volume is always the area of that base, the area of that circle, times the height, which is the 60, and then divided by 3 because it's a cone or pyramid. So that gave us the 7,600. Then for the sphere, volume of a sphere is always just 4/3 times pi times radius cubed. And we divided it by 2 because it's only half a sphere.
Why is it 4/3?
That's just a constant. That's something from the formula. That was one of those things I told you just have to believe me on because it would take us like 11 weeks to drive it. I can show you where it came from.
Oh, that's all right.
I've written a couple of calculus textbooks, so I've done that proof a few times. But there's a difference doing it halfway through a calculus course and halfway through a technical math course. Yeah. Okay. Surface, well, actually, I'm going to skip down to number 3, density. The density is 1.2 grams per cubic centimeter. To find my density, I'm just going to take this times 1.2. So 10,386.23, or whatever you had, times 1.2 is going to give us 12,463.48. That is grams, or about 12.46 kilograms. Somewhere around 26 or 27 pounds. Close to 27.5 pounds, actually, 27.4. So all that is for density is you take the volume times the density, it'll give you a mass. Surface area now. If you look at what we have here, we have half of the surface area of that sphere. So we'll just use the surface area formula for a sphere and we'll divide it by 2. For the cone, we don't have the base. All we have is the lateral area of the cones showing. Okay? So for the cone, we already have the area of the base, but we don't need it. All we need is the lateral area. So for the cone's lateral area, we must first have the perimeter of the base, which is going to be the circumference of that circle. It has a radius of 11, so it's going to have a diameter of 22. Which is, what, 69.08 centimeters is the perimeter of that base. Next, we need S. What's S? Do you remember? S is the slant. 60 is the height of this. And if this were a cylinder, the lateral surface goes straight up and down, so the height and the length of the lateral area are the same. But because this slants, the length of that lateral area is a little bit more than the height. So we're going to make a triangle right here, like this. There's a right angle. This is 11, that's just the radius of that circle. This is 60, which is the height here. This over here is the hypotenuse. A squared plus B squared equals C squared. So 11 squared plus 60 squared equals that. So I'm just going to do this with the square root over it. Gives us 61 centimeters as the slant. Doesn't seem like it, does it? But it is. The longer, when you have one side that's really long and one side that's really short, like that comparatively, it isn't a whole lot of difference in between. So we got 61 is our slant. So the lateral area, if you recall, lateral area is the perimeter of the base times the slant divided by 2. So 69.08 times 61 divided by 2. Oh, let me try that again. (2106.94) centimeters squared. So that's just for the cone, the lateral area of the cone. Remember, the base of the cone is covered up by the sphere, so we've got to find the area of that half sphere. The surface area for a sphere is 4 times pi times the radius squared. Now, since it's only half a sphere, we're going to divide it by 2. That's another one of those constants. Yeah, the 4 times pi times radius squared. So, we're at 759.88. So I mean 2,866.82 centimeters squared. Anybody have that answer? You guys ran out of time getting there? Still got the double circle? Gotcha. Gotcha. So you had like 1,518 for the surface area? Questions? Comments? Please for mercy. Okay, well, we need to have more fun. What color is the sky in your world?
It's like a tealish blue.
Makes for pretty sunsets, I suppose, huh?
Yeah, the radiation.
Why is your top one anymore? I know. I would like to know that triangle.
That one's probably going to be seen. Like the direction this one's going? Okay. Slam your toe in a coffee table? Wow. There's a graphic. Obviously, this isn't drawn to scale. That technically peak goes up way high. Find volume and surface area. For the surface area, I do want you to include the bottom down. Let's see how you do with that one. Okay, let's just take a peek. Volume. Well, we're going to look at the volume of the bottom piece here, the box. The area of that base is just 16 by 12, or 192 square centimeters. So the volume of the box, 182 centimeters squared times 10 centimeters is 1,920 centimeters cubed. Up top, we need to know the height of this. We can find that height, because this is 8 centimeters. That's 17 centimeters, working our way backwards. So this is going to be the square root of 17 squared minus 8 squared. Why is it minus? Yeah, because we have the hypotenuse and we're working our way backwards to one of the legs. Whatever this is, if that were x, it'd be x squared plus 8 squared equals 17 squared. We're working our way backwards, so we're going to subtract the 8 squared from the 17 squared, giving us that this is 15 centimeters of height. So that volume for the pyramid type portion is the 192 centimeters squared, which is the base, times that height of 15 centimeters, divided by 3, not 2. What's that?
Why'd you get 8?
Half the 16. Even though it's not regular, the center of this is in the middle. The peak is in the center of the base.
So is there a term for the ones that have a peak in the center? Really not regular?
Yeah, what is the name for it now? A right pyramid is what it is. A right pyramid has the peak over the center. So that comes out to be what? 960 centimeters cubed. Adding those two up gives us 2880 centimeters cubed is our volume. Make sense? Now for surface area, we have the area of our base down here, which is the 192. You got to have that. We're not going to put the top on because we got the pyramid sitting on top. But for lateral area, we need the perimeter of our base, which is 16 plus 12 plus 16 plus 12, otherwise known as 56 centimeters. So the lateral area is 56 centimeters times the 10 centimeter height, or 560 centimeters squared. Notice these are rectangular, so we didn't have to divide by 2. Then what we have up here is the lateral area of the pyramids. Problem is, it's not a regular pyramid, so we cannot do a perimeter of the base times a slant, because this slant is going to be different from this slant. So what we have here is just triangle by triangle. This is 12 by 17. So this is triangle 1. It's 12 centimeters by 17 centimeters. Because it's a triangle, it's divided by 2, but there's one on the other side, so it's times 2. So that's 204 centimeters squared. So that's this triangle here and this one over here. Now here we need the slant height. Well, we've got that this is 15 high. We calculated that. What's this dimension here? Half the 12 makes 6. So what we've got, 15 and 6, we got to find this, which is going to be the square root of 15 squared plus 6 squared, which is not going to come out perfect. Giving us 16.15 centimeters. So that's our slant times 16. So that triangle, actually should be 16.16, shouldn't it? Not 15. So that'll be 16.16 centimeters times 16 centimeters across here. Divided by 2 and then times 2, because again there's 2 of them. Which is what, 256 or 258.56? Does that look right? Centimeters squared. 16.16 times 16. 258.56. Perfect. So now we just got to add up those 4. 192. 560 makes 752. Plus 204 is 956. Plus 258. Was that 1214.56 centimeters squared is my surface area. Correct? What do you think? Good stuff?
I got the bottom part, I didn't get the top.
Oh, you actually got the area,
Yeah.
all the areas? Cool. And this one's actually a little bit easier because you can't do a perimeter of the base. You just have to go triangle by triangle. And as long as you can find this slant here, and the trick to finding that slant, of course, is finding this height to begin with.
That would be
Yep. Once you find that height is 15, you have to have that to find the volume over here anyway. Once you find that height is 15, it's a little bit easier. Okay, well, we're going to switch gears here just a little bit for a second, because there's something that I think is useful for you guys to know that I want to go over. So I'm going to pass out this worksheet quick. Okay, so the worksheet I just passed out is dealing with taking measurements and converting them to the nearest 16th or 32nd or 1/8 or 1/4 of an inch. And there's two possibilities. Either we can start with feet and convert to feet, inches, and whatever fraction it is that we want. Or we'll start with inches and convert to feet, inches, and whatever fraction. Well, we're going to start with some examples of this here, starting with feet. So let's say that we have 8.734 feet, and I want this to the nearest 1/8 inch. Well, how many feet are there? 8 feet. So it's 8 feet. So we've got 0.734 feet. Our next step is going to be to convert that into inches. How do I convert that into inches? Times 12. So 0.734 times 12. 8.808. That's inches. So that means I've got 8 inches. So take that off. Now I have the 0.808. Now I got to turn that into eighths. I put it over 1. Right now it's got a denominator of 1, but I want it to have a denominator of 8. So I'm going to multiply by 8 on top and bottom. So 1 times 8 is 8. 0.808 times 8 is 6.464. So that is telling me that this is between 6/8 and 7/8. Which is it closer to? 6, because it's 6.4. So it's less than halfway to 7. So it's the 6/8, which is going to reduce to 3/4. So to the nearest 1/8 inch, 8.734 feet is 8 feet, 8 3/4 inches. Let's do another one. Let's do 12.199 feet to the nearest 16th inch. So I got 12 feet. That part's easy, right? I'm going to take my 0.199 feet and convert them into inches by doing what? Times 12, which is going to give me 2.388, correct? Inches. What's that telling me? Tells me we got 2 inches. And I now have to take 0.388 and put it over 1 so I can turn it into 16ths. So since it's 16ths, times 16 over 16 gives me 16 on the bottom. 0.388 times 16 is what? 6.208, something like that. Is that correct? Yep. So that's telling me that we are between 6/16 and 7/16. Which one are we closest to? The 6/16, which will reduce to 3/8. So to the nearest 16th of an inch, 12.199 feet, is 12 feet, 2 3/8 inches. So number 1 on the worksheet, 4.1785 feet to the nearest 16th of an inch. I want you to try that one quick before we go for a break. Yep. How many whole feet we got? 4. So we take the 0.1785 times 12. .142. So that's 2 inches. We take the 0.142 over 1 times what? 16 over 16. 2.272, which is between 2 and 3, closest to 2, which is going to be 1/8, right? So the nearest 16th of an inch, 4.1785 feet, is 4 feet, 2 1/8 inch. Let's take a break. We'll come back at 8:30 and we'll hit this again.